Okay, so for question number 1, for each of the following scientists, describe his invention, the type of energy they were able to produce, and how it was produced. Okay, so Ørsted was the guy that had the current carrying wire over top of the compass. Okay, it was discovered that around the current carrying wire was a magnetic field. So he discovered that electricity or electrical energy could produce magnetic effects. Okay, so his was magnetic effects or magnetic energy. Okay, B, Faraday, his was the opposite. He discovered that a magnet could push moving charges through a wire or cause charges to move through a wire, okay, producing electrical energy. Okay, Seebeck also produced electrical energy, but he did it using a thermocouple. Okay, he converted thermal energy directly into electrical energy, just like the brake rotors of a hybrid car does. Okay, Edison invented the light bulb. He is credited as being the biggest optimist in history. Not really, okay, but he was once interviewed by a newspaper, and they said, "Did you ever get discouraged? You failed so many times to make a light bulb." And he said, "Nope, I figured out about 500 ways how not to make a light bulb." I mean, that's pretty much glass half full thinking. Okay? All right. And then Volta produced also electrical energy from chemical energy using the first battery or Volta pile. Okay, so for each of the inventions identified in question 2, stated practical use of the invention today. Ørsted, electromagnet, also transmitters, transistors, okay, those kind of things that are used to transmit and receive electromagnetic energy. Okay. Faraday, it's a generator. Okay, we use a magnet alternating back and forth in order to produce alternating current. Okay, Seebeck, that's the thermocouple. We use it in, again, the brake rotors of hybrid cars or in circuit breakers. We don't really use Edison's version of the light bulb anymore because it's quite inefficient. It produces a lot of heat. Okay, but I mean, it's still practically the same thing today. And Volta, obviously, we still use batteries. Okay, we have rechargeable ones now, which his, of course, weren't, but we still use it effectively today. All right, what's the difference between nuclear fusion and nuclear fission? How are they similar? Okay, the difference is one splits the atom, that's fission, and one forces atoms together to make larger atoms, that's fusion. What do they have in common? They both release the energy stored within the nucleus of the atom. All right, for number 6, what's the modern theory of the source of energy from the sun? Okay, what causes the sun to make energy?
Nuclear fusion.
Nuclear fusion. The extreme gravitational strength of the sun literally crushes hydrogen atoms together to form helium atoms, okay, which is a much better explanation than the one that people came up with originally, which was the sun is a big fire in the sky. Okay? By that logic, the sun would exhaust its fuel in less than 5,000 years. And also, there's no oxygen in space. You know, that problem as well. Okay, number 9, describe the contributions of the following people. So, Sadi Carnot. What did Sadi Carnot do? Margaret?
He discovered that the transformation of heat into mechanical energy could only occur when thermal energy flows from a hot object to a cool object.
Right, okay. He's basically the person who discovered the second law of thermodynamics could be used to make mechanical energy. If heat was flowing from hot to cold, okay, it could be harnessed as it flowed to do useful work or mechanical energy. Okay? And then James Young. What did James Young do? Remember Thomas Young right here? Okay, he linked mechanical energy to kinetic and potential energy in moving objects, right? Basically, he came up with the idea that mechanical energy could have 2 parts, both potential and kinetic, okay, and led to the current definition of energy, which is the capacity to do work. Okay, Joseph Black, he's the guy who became Count Rumford. He discovered that mechanical energy could turn into heat, okay, and he watched his workers have coffee breaks because of all the thermal energy they produced while boring out cannons. Okay, sorry, I was doing Count Rumford, not Joseph Black. Sorry, Joseph Black was right here. Okay, a cold object placed in a cup of hot water, so that there was this flow of energy from hot to cold. Okay, he called it a caloric fluid, which we later found out isn't actually what it is. Okay, and that second law of thermodynamics, okay, is that energy always flows from high to low. Okay, so sorry, I skipped. Okay, and then so using these diagrams here, explain how Joule proved that potential energy could do work or was capable of, was a form of energy. Okay, not that it could do work, but it is a form of energy, and that's because he used it to turn into heat. Okay, he took the potential energy of any falling object, okay, and found that it could be converted into heat. Okay, the only place that heat could have come from was from the work he did in lifting the block and giving it potential energy. So both of these diagrams explain how that potential energy is a form of energy because it caused a change in temperature in either the jar or the stationary block. Okay, for number 12, given the following situations, identify the major form of energy involved. An antacid tablet is placed in a glass of water and the tablet starts to bubble. What kind of energy would that be?
Chemical.
Chemical, yeah, it's a chemical reaction, right? Bubbles are a sign of a chemical reaction, so that's definitely a chemical reaction. A fluorescent dial on a wristwatch glows at night.
Light?
Light. Yeah. Okay. A downhill skier begins to ski down the slope with increasing speed.
Kinetic.
Yep. Or I would also accept mechanical, because kinetic is part of mechanical. Okay. A tingling sensation is felt on the tongue when it is touched to the terminals of a 9-volt battery.
Electrical.
Electrical. Has anyone ever done that? Yeah. We don't use 9-volt batteries very much anymore, but back in the day, that's how we tested them. Okay, you just go, and you'd get a little, if it was a really good battery, you'd get like a shock, okay, across your tongue. I don't recommend that as a way to test the effectiveness of any high voltage energy storage devices like a car battery, okay, or anything like that. Be very careful about testing it in that way. Right? It's fine for something that's small like that and doesn't have a lot of current. It's actually not about the voltage, it's about the current. Okay? You could have a lot of volts go through you as long as the current is very low. Okay? It's not volts that kill you, it's amps that kill you. Okay? So just be mindful of that. Okay? I was once winterizing our trailer and accidentally connected the 2 terminals across the breaker box for our 6-volt, 12-volt batteries. Okay? And it wasn't about there was 6 volts, it was about all the amps that went through me. I couldn't hold on to a screwdriver for like a half an hour after that because my hand wouldn't relax. Okay? So you've got to watch out for the amps, not the volts. Okay? The inside of a car gets extremely warm if the car is left in the sunshine. Okay, which is also thermal energy, yeah. We could also make an argument for light. It is the light going into the car that turns into thermal energy. Okay, so I would say either one of those would be fine. A seagull lifts a clam high above the beach.
Potential.
Yeah, I'd accept potential. I'd also accept mechanical. And I would also accept, do birds hover typically? I've never seen a seagull really hover in place without actually moving forward or backward. So I'd say kinetic would also be probably, you could make an argument for it. That question is really looking for potential or mechanical, but I think you could make an argument for kinetic as well. Okay, a compass needle held over the surface of the Earth points north. That would be magnetic energy. Okay. All right, describe an appliance or machine that for its operation requires the following forms of energy. Chemical, anything that burns fuel. All right, a car, a lawnmower, a chainsaw, okay, like anything that runs on gas, okay, would be fine there. Light, anything solar powered, your calculator, okay, if it's got solar panels on it, okay, things like that. Heat, a thermocouple needs heat. Okay, that would be a device that would operate on that. Electrical, anything you plug into the wall, anything that runs on a battery. It could be electrical. Okay, magnetic. Speakers require magnetic energy. Okay, so if you ever watch like subwoofers going like this, okay, you can see the cone move. Okay, that's from magnets. Okay, as electrical energy goes through the magnet, it pulls the cone back and then lets it go. Pulls it back and lets it go. Okay, that's what produces the sound waves. Describe an appliance or machine that produces the following forms of energy. Okay, what produces chemical energy? A refinery. Okay, I would say could be a device that would produce chemical energy because it makes gas. Okay, a plant because it uses photosynthesis to make sugar. That would count as making chemical energy. Okay, something that makes light. Light bulb. Anything that glows. Okay, that could even be like a firefly. Okay, for that matter. Thermal energy. A heater, a toaster. Okay, curling iron, a hair dryer, okay, any one of those. Electrical, a generator, solar panels, okay, make electrical energy. Okay, magnetic, an electromagnet, okay, or a transistor radio or anything like that. Okay, questions on any of those? All right. I will give you the remainder of class, which is another 15 minutes or so. You can study for your test tomorrow. If you are writing in learning support, so if you have any accommodations for the test, please go directly to learning support tomorrow morning, and you can start your test by like 8 o'clock. Similarly, if you are wanting to start early, I will allow people to start in this room at 10 after 8 tomorrow. Okay, so if you show up here at 10 after 8, I will give you your test and you can start early. Okay, and that's the best I can do.
What's the market?
No idea. Maybe they use it to sign out library books. That would be my guess.